Hey everyone, I have found a part that is simple enough to practice basic CAD modeling. It's an inline sketch frame. We will be working in FreeCAD 1.1. A lot of you have asked for a reverse engineering tutorial using FreeCAD, so here is one you can follow. In this exercise, you will get hands-on practice with sketches, planes, and modeling by following the reverse manufacturing process step by step. This frame starts out as extruded aluminum, usually produced in lengths of 4 to 6 meters and then cut down to size. After extrusion, the frame is milled into shape. The CNC operator typically has to rotate the part 3 or 4 times on the fixture to complete the cuts. When we reverse engineer it, we will follow the same process, starting with extrusion and then cutting from different orientations, just like in manufacturing. For the 3D scanning, I will use the Creality Scan Raptor Pro in 7-line laser mode. The Raptor can handle black surfaces, but this one has a powder coat texture, so it's better to apply spray for faster capture. The longer you spend scanning and the more distance you travel, the more error gets introduced. A lower frame count scan actually gives better precision and accuracy. When placing the part on the turntable, raise it slightly, about 10 to 15 millimeters is ideal. Setting it directly over the marker dots can cause problems. Before starting the scan, you need to set the right resolution. Since this part is over 20 centimeters long and has mostly flat surfaces, I will set it to 0.25 millimeter. The right approach is to set the resolution as low as possible while still being able to see the detail clearly. Most objects that fit on this 33 cm turntable can be scanned with 7-line lasers without needing to place sticker markers directly on the part itself. For this scan, I will only do 2 passes, front and back. The Raptor precision is high enough that it can reliably merge the data from both sides. This is real-time scanning speed, so you can see exactly how fast I'm moving the scanner. For comparison, I will also scan this frame using the more expensive Creality Sermoon S1. This is real-time scanning speed, so you can notice the difference. The Sermoon S1 is clearly faster, running at 90 frames per second compared to 50 frames per second on the Raptor Pro. Even though this part has a U shape, the 7-line laser was able to capture the bottom, so I didn't need to switch to single-line laser mode. With Creality Scan 4.2, you can now clip the plane after finishing the scan. Using 3 points to define the plane make it much easier to remove the support. A successful scan is one that can be merged. To fully reverse engineer the model, the data must include both sides and merge precisely. For alignment, I use 3 corner points. After this, I will mesh the data with about 2.1 million faces, then export the model in ASC point cloud format. And here from the Sermoon S1, I should point out that not every 3D scanner can achieve this. It takes a certain level of precision to seamlessly align the scan data. Looking at the mesh result, both scanners produced identical output, so if you use the original Creality Raptor, you will achieve the same result since it shares the same 7-line laser module as the Raptor Pro. Looking at the point cloud cross-section, both scanners produce the same result: thin walls, clean surfaces, and constant wall thickness. This condition is ideal for reverse engineering. Point clouds are the only 3D file format suited for reverse engineering because they can be cropped into thin sections for sketch creation. The scanner needs very high precision to produce this result, typically less than 50 micron of error to seamlessly join to scan datasets. In CloudCompare, I select one of the flat surfaces and use 3-point alignment to snap it to the XY plane. Then I rotate it to align to the X-axis, moving the bounding box to the origin, and export the point cloud in the PLY format, which is the only format that works for the FreeCAD. And when prompt, click on ASCII. Next, I will open FreeCAD 1.1 and work in the Part Design workbench. Click on File, choose Import and select the point cloud. I will also include the download link in the description. Tap on the point cloud, change its color and set the point size to 1. Before we start modeling, it's very important to place the point cloud exactly on the mirror axis. Measuring the center between these two walls show only a 9 micron offset, so no adjustment is needed on this axis. Now I'm checking the y-axis using the center of the mounting holes as reference. It shows a 0.1 mm offset to the right, so I will move the point cloud 0.1 mm in the negative y directions. Next, I will create an aluminum extrusion profile. I will start by using the XZ plane to create a datum plane, then offset it 130 mm along the z-axis. Because you can't crop the point cloud in FreeCAD, this view shows the entire depth of the cloud. I will start tracing the profile with the straight line first. Just drag the line past the corner so you can easily move the endpoint for adjustment. Then lock all the lines. That way, when you create arcs and apply tangent constraints, the straight lines won't shift. Sometimes, after applying a tangent constraint, the endpoints won't connect. In that case, just apply a coincident constraint to join them. After creating the arc corners, the final step is trimming. Once trimmed, all the lines should connect. Connected endpoints will show as red dots, while the non-connecting endpoints will appear white. When you have a perfectly closed loop sketch, FreeCAD will allow you to extrude it using the pad command. Click on the part name and set its transparency to 50%. Next, we will create 5 closed loop sketch profiles on the YZ plane, which will be used for extrude cuts. I will turn off the parts of visibility so the point cloud is clearly visible. Then enable the section view. The button is right next to the new sketch button. This will slice the point cloud, making it much easier to trace. When creating 2D sketches in any CAD software, remember to use arcs for continuous curves. Avoid splines. They often cause problems, especially when converting to CNC toolpaths. The sketch tool in FreeCAD has improved. It's now easier to create closed-loop sketches compared to previous versions. While it's still not on par with professional CAD tools, I think it's good enough for most workflows. Now we have 5 closed-loop sketches ready, and we will use the pocket command to cut them from the solid. Next, I will create sketch profiles for cutting the graphics pattern. At first, I thought the patterns were symmetrical, but they aren't. After milling, I had to rotate them slightly to align correctly. Then use the pocket command to cut out the profile. Next, I create a cutting profile on the XY plane. This cut is designed to fit the rollerblade wheels. This sketch frame actually came from my older rollerblade shoes. The wheels were worn out, but I kept the frames to use for this CAD tutorial. I used to play a rollerblade, though not anymore. After pocket cutting, I will mirror the feature to the other side using the default settings. Next, I will extrude cut the holes. The two sides of the frame have different diameters. The smaller one is threaded for M6, while the other is 8.3 mm. I will project the hole from the first cut into the new sketch using its center as a reference point. This allows me to position the 8.3 mm holes accurately on the opposite side. Next, I will click on this plane and create a new sketch. This will define the mounting face under the shoes. This exercise involves creating many sketches, and by now you should understand how planes and sketches work. In any CAD software, the principle is the same. You need a plane to create a sketch, and you need a sketch to generate a solid or a surface. FreeCAD still can't create true 3D lines, and the loft and surface commands need a further development, but it's still great tool for learning. Once you are fluent in modeling with FreeCAD, transitioning to more advanced and more expensive CAD tools becomes much easier. If I have time, I'll make another version of this in BricsCAD. It will be much easier to model compared to FreeCAD. Here is the final extrusion for this part. I copied the slotted holes by projecting them onto the sketch plane, translated them into position, and then turned them into a sketch. The Raptor has an accuracy error under 50 micron, so it's important to trace the geometry precisely. You don't want to introduce additional error into the scan data. One good thing about FreeCAD is that it allows you to save in step file format, which is a TrueCAD file. From there, you can import it to generate CNC toolpaths or bring it into a rendering scene. When you drop a step file into a rendering software, you can choose the resolution. A CAD file itself has infinite resolution, but once it's converted to a mesh, the resolution becomes limited. The green model is the reverse engineered part created in FreeCAD. The purpose of reverse engineering is to convert 3D scan mesh data into a CAD model. This step file is only 0.7 MB compared to the green mesh at 256 MB. A CAD model never loses resolution when you modify or edit it, which make it the most valuable form of a 3D model. Thanks you guys for watching. I'll see you in the next video.